Aloha, and welcome to the historic Kealiiokamalu Church Restoration and Preservation Project. As a community service project, North Shore Land Consultants provided a 3D laser scan, a 3D printable model, and the 2D as-built drawings for a building permit. Let's walk through our process to document this culturally significant and historic building. We meet on site for a project identifier interview covering lines of communication, client objectives, accuracy and precision requirements, and georeferencing. Then we map out our scan plan of survey-controlled traverse and scanner setup points. Systematic planning and execution of our scan plan ensure effective action in achieving project goals. Primary control is a closed-loop survey-controlled traverse encompassing the scan subject. It is the project's geographic anchor, serving as field control during the design-build process. It allows georeferencing to any related GIS mosaic. Secondary control, scanner setup points, are strategically placed for predictable subject structure coverage, interference avoidance, quality control checks, plus interior and exterior data capture coupling. We used a Leica C10 scanner with auto-checking protocol. The scanner spatially orients itself at each position using a direct registration method called known backsite. By applying standard survey traverse methods to position the scanner and the target rods, we automated point cloud registration, dramatically increased the point cloud's positional accuracy, removed the need to place registration targets on the structure's surface that can block architectural detail, and we eliminated all the post-processing time and the use of constraints needed to complete an indirect point cloud registration. Our unique method of utilizing a scan plan, auto-checking protocol, and standard survey traverse methods greatly reduces post-processing time while optimizing the point cloud's registration results. It's a better product with real-time savings and predictable quality. Colors on these images indicate which scan position collected each of the 38 million data points. For instance, data points from position 113 are in red. Those from number 100 are blue. We registered the 13 individual scans into a single point cloud using the known backsite direct registration method. Registration was automatic, immediate, and above all, accurate. A reliable and accurate registered point cloud and its corresponding survey and scan control traverse are the foundations for all client 3D laser scanning deliverables. This is the main deliverable. All other deliverables are built from this registered point cloud. Quality control accuracy checkpoints were survey field ties to distinguishable physical features. The checkpoint coordinates were compared to the corresponding registered point cloud coordinates. Our project was within plus or minus 15 thousandths of a foot horizontal and plus or minus 5 thousandths of a foot vertical. Polygonal meshes are existing as-built scale three-dimensional models that can be used for analytics such as physical condition monitoring and deformation studies. The church's mesh was developed into a 3D CAD model. The deformation and out-of-plumb conditions of this aging structure were eliminated, depicting the church's condition when first built. With a few extra clicks of the mouse, the model was ready to 3D print. The printable model has a removable roof, shown in red. Measurements on the screen captures show our quality checks. This 3D CAD model was also used to create scaled, accurate, highly detailed 2D architectural drawings. The church's original construction blueprint drawings no longer exist, but now the church has modern digital plans. For buildings over 50 years old, both the City and County of Honolulu Department of Planning and Permitting and the Hawaii State Historic Preservation Division require pre-repair and post-repair scaled drawings for the repair permit application. Our 2D architectural drawings secured a building permit and were used for construction material takeoff calculations too. They were instrumental in the preservation and restoration process. And, of course, these are more deliverables. In conclusion, 1. Identify the project objectives from the very start. 2. Develop a scan plan to effectively carry out the fieldwork. 3. Optimize the point cloud registration results. 4. Use primary control to seamlessly incorporate the 3D model into any related GIS mosaic. Remember, georeferencing, along with accurate point cloud registration, is integral to the success of any 3D laser scanning project. And 5. Check, check, and check again. We hope you've enjoyed this walk through our 3D laser scanning methods and deliverables. Please visit our website, northshorelandconsultants.com, to learn more about our survey-based projects and technologies. You can find a link in the description below. Thank you, and aloha!